course it's not using the right thingy. If I click, okay, not using the right thingy. Alright, so I'm going to talk loud again today.
You're going to yell at us again?
I'm going to yell. Well, hopefully I won't yell at you, but I'll just
Well,
talk
like
loud.
a yelling lesson.
Okay, we're going to do coefficient of determination and the standard error of the estimate. What that's going to look like, so I have to remember to click both things today. Let's find where my mouse is on the computer. Over here. Maybe? Is it going to do anything? Okay. The total variation looks gross, so let me rewrite that one. That one's wrong up there too. Where the heck is this in the book? Okay. We have the total variation is the sum of the y minus y bars all squared. Is the sum of the squares of the vertical distances each point is from the mean.
Are we going to actually have to use this one? Or does our calculator do it too?
I don't think the calculator does this one. We might be able to make the calculator do it, but we'll have to see for sure. Alright, I don't know. Yeah, we'll just do it by hand right now because I don't know of a way to make the calculator do it. The total variation can be divided into two parts, which is attributed to the relationship of x and y, and that which is due to chance. Okay, so there it is again. Were those the same? They were the same though, right? Minus y squared. Both of you though. Peanut butter and the gum. Okay, the variation obtained from the relationship.
You sound like a dog.
From the, this is a little bit different. So this is the explained variation. So the explained has that y prime in it. And y prime minus y bar squared. I wish I could pause this thing. That would just be great. Okay.
What?
The swivel part of it.
Mm.
Did I click for the next one? Okay, there it is. So the variation due to chance is found by blank is called the unexplained. These are the same. Oh no. So the explained one and then the unexplained one. I should have made sure I checked out how all the formatting went. Okay. The unexplained part is y prime minus y squared. I'll make my little y tails a little bit shorter. Okay, so that one, the explained has a y bar on it. Okay, so the total deviation, when we think about it, is that y bar is that average. So the average of the whole total, all of the things. So we can make our calculator find our y bar for us. Okay, so that y bar is something we'll find in the calculator. The total deviation is y minus y bar, so each point. So this is to the average, and then the line y is actually the y equals line that we're talking about. Okay, let me click that for that guy. So the total deviation is the explained one. So that is from the average to the point. Okay, the coefficient of determination is the ratio of the explained variation to the total variation. The symbol for the coefficient of determination is r squared. Okay, so r squared is the explained variation over the total variation. And this guy up here was the total variation. Okay, so explained over total, and then make sure that you write that that is the coefficient of determination. Okay, another way to arrive at the r squared value, the correlation coefficient. My nose is gross. The coefficient of non-determination is a measure of the x-plane variation. The formula for the coefficient of non-determination is 1 minus r squared. And I think that's it on that guy. Okay, so the coefficient of non-determination is 1 minus r squared. Where did we use that guy at in any of your questions? I must ask you some questions about coefficient of non-determination. I don't know, I don't see questions. I see it like in there, but I don't see the questions about it. Okay, standard error of the estimate is the S estimate is a symbol for it. And is there more stuff? That's pretty much it on there. Okay, so it is about the observed y values and the predicted y prime values. So y prime is just those predicted values. Okay, standard error of the estimate. So I'm hoping we should be able to use, we'll figure out how to do everything with our calculator as much as we can in a few seconds. So just get all your formulas. You have your formulas written down? I'm going to write this one down so I don't have to come back to it. You're killing me. Okay, so it is just the x-plane. Which one is that? That is the backwards one, so it's not anything. Y minus y prime squared over n minus 2. So we'll have to do that guy. And they just keep getting grosser and grosser formulas. Okay, so now let's actually do an example with it. So example 10.3. No, in 10.3, example 10.12. My gosh. And they have figures and examples and crazy things all over. Okay. So a researcher collects the following data and determines that there is, let me click this one through, that there is a significant relationship between the age of a copy machine and its monthly maintenance costs. I have the regression equation of y prime is 55 plus 8.13x. Find the standard error of the estimate. So the standard error of the estimate, I need the y values, which I already have the y values, and then I'll need the y prime values. So we're going to go through basically adding to this chart to find the y prime values. Okay, so we're going to get a calculator, unless does the next thing do it for us? Okay, so I'm going to skip to the next thing so I don't have to draw the thing. Okay, so the y primes. I need to write down that equation that they gave us. And they said it is y prime is equal to 55.57 plus 8.13x. Okay, so now we're going to plug in 1 into that thing. Okay, and then we'll get our y prime for each of those numbers. So we'll plug in 1, 2, 3, 4, 5, 6 into that equation just to come up with those numbers. Okay, so this is, you'll have to do this. You'll be basically making this chart for all these things. I don't know of a way to make your calculator do it. Like, I mean, you can type in, let's type in the y equals into our calculator. So I'm going to type in. Why are we doing
less? Where is that at? Like how you did y prime, what you just wrote down. Where is that at?
This? Mm-hmm. This is the equation they gave us.
Oh, okay, gotcha.
That it seems like they will give you. If they do not give it to you, it is where you get that lin-reg piece in the stat calculate menu.
Gotcha.
Okay, so yeah, they just give that to you or you find it because of these data points. Okay, so there might be an extra step. I lost my mouse again. There it is. So come back over this way. Okay, so the nicest way to do this, I'm going to say in the calculator, is go to your y equals menu. In your y equals menu, you have 55.57 plus 8.13x. And this way, at least, that we don't have to type everything in 100 times. Okay, so now I'm going to use that calculate menu. So it's very large, so it doesn't fit on my screen when I'm looking at the graph. I don't really need to look at the graph though, so I can just do my table values.
Mine did the points thingy.
Points, 0.25.
Like a stat plot.
Okay,
Like
so you need
scatter
to turn
plot?
your stat plot off. So to turn your stat plot off, you can go to your y equals.
Can I
And-
just do plot 2?
We don't need a plot.
Oh, plot?
No, we don't need
So
a plot.
what's- Okay, so y equals?
What?
Y equals?
And go up,
Uh-huh.
and
It's on
your
top.
stat 1 is highlighted.
Uh-huh.
Click enter, and it should be unhighlighted.
Yeah.
So now it will go back off.
Graph.
Okay.
Graph.
Now I'm going to look at my table of values. So second graph. And at 0, I don't need 0. At 1, I have 63.7. Oops, I better write a little bit smaller if I want this all to fit. 2, I have 71.83. So I'm not having to go actually type everything
How do you
in.
get it to like zoom to where you can actually see what's going on?
I don't need to see the graph.
So where do I go?
So I want to go to second graph to see the table.
Oh.
Okay.
Never mind.
And then I just want to see like the 1 values, the 2 values, the 3, I have 79.96. That's a 6, 88.09, 96.22, there's a point in there, and 104.35. Okay, now I actually have to do a little bit more typing and stuff in the calculator. So what is y minus y prime? So 62 minus 63.7.
Where did you?
Negative
The six-
One. Sorry, I was at -2.
No, negative 1.7.
78 minus 71.83.
Wait,
I have to do each of these things
Come
now.
on, Math Wiz, let's go.
Yeah.
but, oh, okay.
And we're just making a totally another column.
Oh no, I thought something was wrong.
Wait, so how do?
7.
Oh, you have to subtract it. Gotcha.
Yep. So just title your columns
6.17.
so that you remember what to do. 6 point what?
17.
Okay, next one, 9.96. Negative 9.96. 90 minus 88.09 is 1.81. 93 minus 96, negative 291.
That's 9-1.
Sorry. Good, I'm glad you're checking my subtraction skills. Okay.
Teacher.
Yeah, no, I hate subtraction.
Negative 3.22.
103 minus 104, 1.35, negative.
Oh, that's a 9-1, not an 8-1.
Sorry, I typed in, I wrote
No,
8-1.
so, yeah.
Okay, so now I need to square all those numbers. You don't have to pay attention to the negatives. Remember, all squares are going to be positive. So I'm going to have 1.7 squared. So these are at least nice to type into.
2.89.
So tell me, yep.
Oops. Oh, no, I put it wrong.
I really like your
38.07.
Okay, 996.
99.20.
1.19. No, 1.91. No, let's look at what I have. Don't listen to me. 1.91.
3.65.
3.22.
10.37. 1.82.
So I have all of these things. So finding the standard error of the estimate. I have this guy. Remember that I need to basically make columns for each of these things, whatever they happen to be. Okay, so if I needed a y bar, I would just need to like write my y bar to remember to subtract it. Okay, and then over n minus 2, how many data points did I have? I had 6 data points minus 2. So I'm going to have, now I need to add all these things up. So add up all these square things.
I gotcha.
And I guess I don't know a way to make my calculator do this. I'm sorry about that. So whatever that number is when we add them all up, will be over 6 minus 2. That will be the standard error of the estimate.
156.
156. Even?
Yeah.
Really?
I think so. Unless I
Yeah, got it even too.
Oh, okay, cool. So 156 divided by 4.
39.
So the square root of 39.
6.245.
2, 4, 5. Okay, so S estimate is equal to 6.245. So let's hope they have a little bit. They have 169, so they must have done. I'm looking. Where's my clicker? So we had the 63, 71, 79,
Why do they
88.
have 50? Oh, okay.
Oh, they didn't have a. Oh, I didn't notice that this was on 5. So this whole row of ours is wrong.
Oh.
I
Yeah,
didn't notice that
at least
either.
At least we did something close to it.
Yeah, we did. Same idea. Just pay attention to what the heck you're looking at. Okay, so we had slightly off numbers because of that. Everywhere else, so if we had 1, 2, 3, 4, 5, 6, that would have been our problem. Okay, correlation and regression. Let me find this clicker. Did I go too far? 13, what example was that? Okay, so this will be it. Okay, so have all our formulas just handy so you can work with them. Where's my clicker? Okay, the standard or the estimate for the data in example 1012 by using the formula below. The equation of the regression line is that same thing. So we want the sum of our y squares. So this is kind of a pain in the butt because I just erased all that stuff. Okay, we didn't have y squared though. And what the heck? Oh, A and B is your B is your slope and A is your y-intercept. So this guy is the A, this guy is the B. If I forget those, I usually I just picture it in my calculator and it says A plus BX, which is always backward because B used to always be our y-intercept. Okay, so we write out all our things that we're gonna need. So let me write out my formula again
Hey,
for
that's
that.
really cool. Did
Okay.
you do it for us?
Yeah, no, that's why I just didn't want to. Okay, so I need my sum of my y squares. So I'm gonna have to have my y squareds. So those are one of the things I'm looking for a lot. Minus a sum of the, that's not a sum sign, of the y's, minus b times the sum of the xy's.
Can I get a foreign
over-
language credit for this?
Maybe.
And all this weirdness?
And that is still S estimate. So why do we have two of the same formulas for standard error of the estimate? Are we going to come up with the same answer?
Oh wait, that's standard error of the estimate? Okay.
Yeah.
Should probably remember that.
But that's what the other one was too. So why do they have two formulas for it? Because the other one was not a terrible formula. I mean, it was a little bit gross, but not. Or are they just going back to the really old stuff? Oh, it's just can also be found using that formula. That one's grosser. We're not going to use that one. Okay, so we're going to skip this guy because we didn't like using that many columns because that's just gross. Okay, so now the example using, did I write down the standard error of the estimate? I should have wrote it down. And no, neither did they. Oh, but this is different. Maybe they just asked a different question. Okay, but anyway, we're going to go to 1014, which is using the same data. So we don't have to type, or we didn't really type it in. Okay, they said the standard error of the estimate was
So should I,
648.
cross that all out then?
The one that we did?
The big one.
The big, yeah. Yeah, we're not going to use that gross equation. That was really gross. It's just so much that why would I want 10 columns to do what my 2-column thing did before? That's kind of how I think about it.
I like it. I like your style.
So what
Okay.
many equations crossed out?
Yeah. What is this? This one says 1014. Oh, it's just kind of backwards here. Okay, so we do want this one. This is longer, slightly grosser, but we do want this one.
Oh,
We do want this one?
We do want this one.
Why?
There it
That
is.
one, like the one we just
Okay.
X'd out, looked way better than all
It
these.
did, yeah, I know. Okay, yes it did. Our calculator, however, I know does the X bar. It does the sums. And it does, I don't know if it does the sum of the x squareds. It might not do the sum of the x squareds. Lets me decide if it does the sum of the x squareds. No, I don't.
This looks horrendous.
It does do the sum of the x squared. So our calculator at least is gonna do,
Almost all of it.
yes. So we just will have to know where to plug it in the formula at. But the calculator is gonna do it for us. So we're happy there.
Hold on, because I still have to do the next one.
One,
Yep.
two.
So remember that they're the same thing. The only difference is a plus or a minus.
Oh
Okay.
yeah, that's all the difference I could tell.
Yep. So make sure you have the same thing written down and check all your signs and everything. Take a picture, maybe two. Okay. So our y prime, that was still that prediction equation. Our t alpha over 2. Remember, we're using that t alpha over 2 when we have a two-tailed test. And we usually used it when that's where the alpha over 2 part comes from, is that it's two-tailed. And then the t-score was when we usually did not know the population standard deviation.
I just want to
So-
keep writing E's for those big sum of things.
And I
Just a big letter E.
it's your notes. Okay. Close, got it? Okay. So now, to use this stuff, I don't want to write it down. So I'm just going to keep it right here so that I don't have to write it down on the board too. Okay. Find the 95% prediction interval for the monthly maintenance cost of a machine that is 3 years old. Is this the same data still? I guess so. I guess that's what it was all about. So find the sum of the x's, the sum of the x squareds, and x bar. Okay? These are all things your calculator does for you. You can add them up, you can square them and then add them up, and then you can find the average. The average you can do by yourself anyway. Okay, let me click these things through. Okay, but really just type the data in. So you would have already typed the data in, and then just go.
Is that all under like list stuff too? Is that where this all comes from?
This
the list,
is-
and then you do your like LinRig thing.
Yeah. So you can do your. This is not under the LINREG. This is the 1 and 2 variable statistics. I don't think I have anything in my L2. Otherwise, it would give me my 2.
So you do your list, and then you do calc, and then you do 1 and 2 variable statistics.
Yeah, so I do my stat. Yeah, if you have both things typed in, you should be able to find your 2 variable statistics, and that will also give you that X bar.
I just
Or the
want to
XY.
write these down so I actually know what I'm going to
Yeah.
do with it.
So it is stat, calc, and depending on how many columns you have typed in, if you have 1 column typed in, you want your 1 var stats. If I have my 2 columns typed in, I want 2 var stats. And I think they pretty much give you all the same thing, only the 2 var stats is going to give you like twice as much.
Okay.
Plus 1, I think, is about what that guy should do. Okay, so we'll find y prime for x3. So because I have a 3-year-old machine. So my y prime for my x3, that is going to go at the beginning of my equation where it mentions y prime in there. Okay, so I'm basically going to have 3 plus or minus that big long row stuff. So I'll have that t alpha over 2 is where I'm going to find my 95%. Okay, that's going to be that t-score. Okay, so finding, oh, whoops, I didn't actually find y prime yet. So plug in 3, not 3, but plug it into the equation, and you get that 7996 plus minus, not 3. Okay, to find that stuff, we're just plugging in everything we know. We already found the estimate, so where does the S estimate go? Come on. Did it click for me? I really just would like.
This is ridiculous.
It is gross. Okay, so your t-score, we would have had to go use our chart for that, for the degrees of freedom, for the right degrees of freedom. The 648 is that t-score, so I don't. Where the heck is my formula? So it's t alpha over 2 times S estimate. Did you guys make sure that it looked like it was a times in there?
Yeah.
Because that one, like between these two numbers, it was like, it looked like t alpha over 2 S estimate. So did you guys make sure that it was like Like, I would put parentheses in there just because it's gross. Okay, these things, you know that we only had 6 things. Calculator gives me all those things. Okay, so the only thing you should have to do this whole piece all together. And then just do 79.96 plus that thingy for that one, and then minus for that one. Okay, it should just be calculator stuff. And then making sure you're plugging stuff into the right place. What was the point of that? That was weird.
I
Okay.
don't know, but can I take a nap now?
That's how I'm feeling too. Okay, so after we plug everything in the calculator, we should just be able to say, that was 1943 when you got that big, long, gross stuff. Just came out in 1943. Doesn't come out that gross, and it shouldn't be crazy either. Okay, so between 60.53 and 99.39 is how much it should cost for whatever it is we're trying to do a machine that's 3 years old. I don't even know what we're trying to do to a machine that's 3 years old. Fix it costs, I think. Okay, so then you can be 95% confident that the interval will be between there and there. Okay, I realize it's gross. I know. So I will help you with calculator stuff.
Question test again.
We can probably have like an 11 question test again.
I feel like 7.
I might be too. This is the last section. So I think Monday,
There's only 2 sections?
that was the third one.
Wait, there's only 3?
And that was it. And that was the third one.
Holy crap! Yeah,
So-
7 question
so-
test.
Yeah.
Whoops.
Whoops.
Uh-oh.
That was weird.